Hash table. Hash table is a data structure used for efficiently storing and retrieving data in order to allow quick access. This is done with the help of a hash function which converts input data into a hash value. Once this hash value is obtained, this is used in order to determine where in this table should you insert the input data. So this is the purpose of hash value in a hash table. Next question is, why should you use this hash table data structure? You have a lot of other data structures using which you can input data, have quick access and so on. For example, we learned about arrays, we learned about linked lists, trees, heaps, binary search trees, etc. All these can be used for storing data, it allows for quick access and so on. So why exactly should you have hash tables now? The reason is hash table allows all these operations, that is insert, search and delete these operations at order of one time. That is, all these are constant time operations in a hash table, while coming to all other data structures like arrays, linked lists, etc., all are not constant. There will be some data structures which may allow some of these as constant time operations. If you take arrays, you can insert at a particular index by directly accessing that index. Similarly, if you want to delete a value from some particular index, you can do it in order of one time because you have direct access in arrays. But in that case, if you want to search in an array, unsorted array, it will take order of n time. So similarly, for each of the data structure, some operation will take higher time. This is the major problem. In order to rectify this, you have hash table. So this is whenever you want to just store data and retrieve data. You can't do any other operations. For example, in an array, if you have an array, you already inserted many elements. After inserting, you can manipulate position of elements. Let us say at index 0, I have some element, and index 2, I have some other element. And I want to exchange the elements that are present in index 0 with index 2. So these things I can easily do in array, but in a hash table, you can't control these things. You have a hash table, you'll define a hash function which will allow you to insert it into hash table, but then you don't manipulate anything inside this hash table. You only use this hash table as a storage space. Whenever you want to store some value, you can store in it. Whenever you want to retrieve it, you can retrieve from it. This is the speciality of a hash table. And these particular operations that you can do, that will all be done in order of one time. So this is the speciality of a hash table. Next thing is, what we'll do, we will first see how a hash table works. We will just take an example and see how hash table works. Let us say this is my hash table. This is my hash table. I'll have a hash function for this hash table. What is the importance of hash function? I told you that hash function is what decides where in this hash table should you get a value entered. So this is my hash table. I have to define a hash function. Let us say my hash function h of x says if input is some x, then I should do x mod 10. This is my hash function. What will it do? X mod 10, which means it will take any number and provide whatever is present in the least significant digit. That is what happens when I do mod 10. If I get 123, what will it do? It will provide me 3. That is what 123 mod 10 will be. What will this do? This means if I take any number, if I have any number in the world, that has to map to one digit among 0 to 9. This is what happens because you are mapping complete number to a single digit. What happens then? Let us say my hash table has 10 entries. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. I'll just redraw this. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is my hash table. I can now name this as 0, 1, 2, 3, so on. What happens now? If I take any number, I can map that number into this hash table. After that, whenever I want to retrieve, I can simply use the same hash function in order to understand which is the block my number is present. So I can do this in order of one time. How can I do in order of one time? Running this hash function, it works in order of one. Once I know the exact index to be inserted, insertion takes order of 1. Similarly, if I want to fetch, again using the same hash function will take order of 1. Fetching the value from that index will also take order of 1, which means I can do search, insert, delete, all this in order of one time. Let us insert some numbers into this and understand. If I want to insert number 20, where will I insert 20? I'll do 20 mod 10. What will happen? I'll get 0 as the answer. So I'll insert 20 in 0. Let us say my next number is something like 432. Where will I insert 432? I'll do 432 mod 10. I'll get 2. So I have to insert 432 in index 2. So I'll insert it here. Let us take another number, 628. Where will I insert 628? I'll do x mod 10, 628 mod 10. I'll get 8. So I'll insert in index 8. I'll insert here. Let us have one more. Let us say 434. Where will I insert? In 4. So in 4, I'll insert 434. So this is how hash table works. But then you will have a doubt. What if I get 222 as the next number? If I do mod 10, this is also supposed to go here. So that means I can't insert. If I have to insert, I have to take out the previous value. This is the problem whenever you are using hash table, because what are you actually doing? You have a small space called hash table. You have a very large range of input space. From this larger range, you are mapping into this smaller space such that a lot of points in this greater space maps to the same point in the smaller space, which also means there are many points in input space that can map to the same point in the smaller space. This will cause something called collisions. That is what you are seeing here. What is a collision? When two different keys produce the same hash value. So this is your hash value. What happened here? Both the numbers 432 as well as 222 prepared the same hash value 2. So whenever your hash value is same, it will all map to the same point, that is the same entry. This is the problem whenever you are dealing with a hash table. Next question is, how do you deal with this problem of collision? How will you resolve this collision? This is one major aspect of deciding how good a hash table will actually function. So this collision resolution techniques, there are multiple collision resolution techniques available. One major technique is chaining. Another one is open addressing. So we'll learn in detail about all these types of collision resolution techniques in the coming lectures. For now, just understand that there will be collisions in any hash table, and the way you resolve those collisions using collision resolution techniques is what actually decides how good this hash table can function. Because if your collision resolution technique is not so good, then again instead of order of 1, it may go to somewhere like order of n. So this is the problem with hash table. We'll see how this is to be dealt with in the coming lectures. Next thing is, in a hash table, there are some values you have to know. One is load factor. There is something called load factor for any hash table. What is the load factor? It is the ratio of number of stored entries in the hash table to the number of slots in the hash table. Okay, so what is the importance of this number? Because number of stored entries means how this hash table is already filled. That is what it shows. And what does number of slots show? That shows how much you can fill to the maximum. So if your load factor is very near to 1, what does that mean? That means you already have filled most of the slots that are available in the hash table. You can't add more of entries, which also means there are higher chances for collision. So whenever your load factor is higher, collision probability is also higher. What is the reason? Because load factor is higher means compared to the total number of slots you have available, most of your slots are already having some value stored. This means there are very less entries which are empty and you have a higher chances of collision. So generally load factor will be a fraction. So whenever this fraction comes close to 1, something like 0.9 something, you should understand that probability of collision will increase. Then there is something called perfect hashing. Perfect hashing is when for a given data set, there is no collision that occurred at all. Then you call it as perfect hashing because it is perfect because collisions didn't occur. You were able to easily add each entry into one particular index. Next thing is, what are the applications of this hash table? Why are you learning this? Where exactly will you use this data structure called hash table? So first thing is, we already told that whenever you want to store and then retrieve and you want to do both these in quick time, this is when you use hash tables. This hash table concept is used in Python's dictionary data structure. Python has something called dict if you used Python. That dict is a hash table. Similarly, Java has hash map. Hash maps in Java is also hash table. So that is why you are able to use these to enter as well as retrieve value in order of one time because they are using hash tables inside. And more than hash table, this concept of hashing, that also has a lot of importance. We told concept of hashing is using a hash function in order to generate a hash value. So this hash value, the importance of this hash value is it some way works as a signature or a shortened form of the complete data, because using that hash value, here we took a very basic function xmod10. Generally, when you use a standard hashing algorithm, you get a large hash of each data. For example, you have very huge amount of data. When you hash it, you get a comparatively smaller but still a bit of data. So using this, you can identify this particular data from other data. So this is one use of hash value. Using this, you can do data integrity checks. What is it? Data integrity checks. So whenever, let us say you have a lot of data coming in and you want to verify whether the data that you received is actually the data you are expecting or not. What can you do? You can just have the hash value provided to you by the sender, and whenever you get the actual data, for this data you can generate hash value using hash function and then verify whether the hash value is correct. So this is how you generally check data integrity. There are many hash functions like SHA-256 and all which ensures data integrity. Then in cryptography also you use the same technique. That is, whenever you want to secure some using hash functions in order to protect some sensitive data, then you use hash value. So these are the uses of hashing and hash table. Okay, so other uses include many other things like load balancing, or maybe in databases you may use it for indexing. So this is the use of hash table. Okay, this is the hash table data structure.